Hello, we are working on lesson number 2 from unit number 3, solving quadratic equations in our MCF3MI math class. The second lesson picks up where the first lesson left off, which is us talking about different methods for solving quadratic equations. This little recall here, the part at the beginning of the lesson, goes over what we did in the first lesson in the unit, which is solving by rearranging and taking square roots. So we would do this on occasions where we have our quadratic equation in either vertex form or standard form with no bx term. Basically, if our x is only found in one location in the equation, we can rearrange and square root in order to find the solutions. How many solutions are covered in these first three examples? So if we look at this first one here, again, we find our variable x is sitting there. What's happening to x? It's being multiplied by 4 and squared. So how do we undo that? We're going to follow the opposite order of operations. So BEDMAS backwards. So we're going to undo multiply by 4 first, which gives us x squared equals 0. We take the square root of each side to get to x, and x will then equal 0, which is 1 point. So I've sort of made a little drawing over here of how that might look. The idea, of course, is that a quadratic equation is like a quadratic function where we're only interested in the points that cross the x-axis. So we could, in this case, might have a parabola that is sitting on the x-axis. We're not concerned with the whole parabola. We're literally just concerned with that one point that sits on the x-axis. So we would have one solution here. And our second example, we have x squared equals minus 16. We take the square root of each side, but we can't, at least in our course, find a real solution for the square root of a negative number. If we were in the 11U course, we would be looking at complex and imaginary numbers. We're not going to be doing that, so we have no solutions here. And in terms of how that might look, again, a little drawing I've got on the side there, we have a parabola that opens up or down, but it's above or below the x-axis, so there are no x-intercepts. And again, if we're just ignoring the function itself, then all of a sudden there are no x-intercepts, no real solutions. The third possibility is right here, where we have, again, multiple operations to undo. We end up with two solutions at the end, and taking the square root of 25 over 16 gives us plus minus 5/4. How that might look as a quadratic function is like the little drawing I've done there. But again, if we're not concerned with the function itself, if we're just looking at the places where it crosses the x-axis, then x-intercepts become solutions. And in this case, we have two of them, as we will often have two of them. But what if our quadratic isn't in standard form without a bx term or vertex form? How can we then go about solving for quadratic equations? The first way we're going to look at is solving by factoring. So I've completed the first two examples here for you, and I'm going to zoom in on them a bit so you can see them, and I'll talk our way through them. So solving by factoring, we need to remember what are our different methods for factoring. It would include common factoring, simple trinomial factoring, tricky trinomial factoring, factoring by grouping, and differences of squares. Those are the ones that we covered in our unit 0. So this first example, 3x squared plus 15x, the greatest common factor in both of them is 3x, which as you can see I have factored out. And it leaves me with, in a bracket, x plus 5. Now, what I've done by factoring is taking two terms, 3x squared plus 15x, that's two terms, and by factoring it, I've reduced it down to one term only. So I have 3x bracket x plus 5. That's a single term. That's two things being multiplied together to give us a single product. So by going from two terms, where we started, to one term, that gives us the luxury of knowing that no matter which component of that resulting term, either the 3x or the x plus 5, if either one of them is equal to 0, 0 multiplied by anything else is going to give you 0 as well, which is our goal. We want the left side of this equation to equal the right side. So one way to set that up is to take the first component of our resulting factored term, which is 3x, and set it equal to 0, and then isolate x. So I have 3x being set equal to 0. I divide both sides by 3 and find that x is equal to 0. I take the second component of that term that results from factoring, x plus 5. I set it equal to 0. I isolate x by subtracting 5 from both sides, and that gives me x equals negative 5. So what we've done by factoring is essentially taking a group of terms and getting it sort of concentrated into a single term. And then we can take the components of that resulting factored term and set them equal to 0 and find values for x that will make this equation true. Second example is very similar to the first one, x squared minus 6x equals 0. We common factor out x, and we're left with x minus 6 in brackets. We set each of those components of the resulting term equal to 0, and then isolate x. The first one's very straightforward. X is equal to 0. Nothing more needs to be done. In the second one, x minus 6 equals 0. We bring 6 to the other side, adding 6 to both sides to isolate x, giving us x equals 6. The only thing that's different throughout the remainder of this lesson is the complexity of the factoring. So let's look at this example here. We have x squared plus 8x plus 16. So what I'm looking for is so this is a simple trinomial. I want to find what multiplies to plus 16 and adds to plus 8. Now this factor review, as I said, was in Unit 0, so you can go over ways to factor from those lessons if you're struggling. So as I look at my factor sheet, or if I just know it, I know that the values I'm going to be looking for are x plus 4 and x plus 4. And in terms of form, it's important to keep that equals 0 coming down the equation with you. So now we have two items. Our resulting factor has two components, the x plus 4 and an x plus 4. So each of these will be set equal to 0 in order to find out which values for x will make this equation true. Now it just so happens that in this case the two binomials are the same, which means that x equals -4 and x equals -4 will be the answer for both. So there really is only one solution for this particular quadratic equation. Hopefully that makes sense. That's how you do a simple trinomial. Let's look at example D, and we're going to see that we've got ourselves a tricky trinomial here. So I'm going to solve these using I'm going to factor them using decomposition. So I want to find the item that multiplies to -20. That's the product of my A and C values, and which adds to my B value, which is -8. So now I'm going to look at my factor sheet and try to figure out what those terms are. The terms here will be what multiplies to -20 and adds to -8. That would be -10 and +2. So again, if you're not familiar with decomposition, essentially what we're doing is we're decomposing the middle term in this trinomial down into the two original linear terms that gave us -8. In this case, that's -10x and +2x. And now we're going to factor by grouping. I'm going to common factor the first two terms, and then I'm going to common factor the second two terms and see what we get. So in common factoring the first two terms, the greatest common factor to both of them is 5x, and that will leave me with 2x, sorry, looking a little bit ahead, lost my place, x minus 2, I should say. And I'm going to common factor the second set of binomials, which will give me +2, and in brackets x minus 2. And again, I'm carrying that equals 0 down with me, which is important. So now I have two terms left again. I have this big term and I have this big term, and I'm now going to common factor those two terms. The greatest common factor to these two terms is the binomial x minus 2, which leaves me with, when I factor it out, 5x plus 2. And again, that whole thing's going to be equal to 0. So now it's been factored. From here, as before, I'm going to set each of these factors equal to 0, because no matter which of these two components of my factored result are equal to 0, it will drive the whole thing to be equal to 0. That's the nice thing about multiplying by 0. So now I'm going to reorganize this, transpose the 2 over to the other side. That gives us x equals 2. Here we've got 5x equals -2 and x equals -2/5. So those are my two solutions. This, as I said, is an example of factoring a tricky trinomial. I'm going to jump over example E here. This is another tricky trinomial, so you can copy this one from the notes or try it on your own and then compare it to the notes. I do want to go over the last example, however. This one is factoring a difference of squares. So as we recall, factoring differences of squares, we want to find the square root of the first term, the square root of the second term. One gets a plus and one gets a minus, so that will be 4x. That's my first component. One gets a minus, one gets a plus, and the square root of 25 is 5. So there are my two binomials. And again, remember, now this is a single term. I can set each component equal to 0. 4x minus 5 equals 0. And the second component, 4x plus 5 equals 0. And now I'm going to isolate my variable. So 4x equals 5 and x equals 5/4. And in my second component, 4x equals negative 5, x equals negative 5/4. So I end up with two solutions here. What I want to point out also is that this example F is similar, actually identical, to the one that we did up above that we did by rearranging and square rooting. Just to sort of proof of concept that no matter which method you use, you will be arriving at the same answers. So I'm not going to spend any time on the second page of this lesson. If you want to copy it down from the completed notes, that's awesome. It's really meant to help you see the relationship between how you can have a quadratic function, what that becomes as a quadratic equation, how the x-intercepts of a quadratic function correspond to the roots or solutions of a quadratic equation. So it's sort of an explanation. It's not necessary to the big picture understanding of solving by factoring, but it does hopefully develop your understanding of what's going on more broadly between quadratic functions, which was kind of Unit 2, and quadratic equations, which we're working at in Unit 3. So our homework is at the bottom. There it is. Feel free to dive through that. You can email me with any questions that you have, and good luck.